So, welcome back to another session. So, here we'll be understanding about the TCP header in a very easy way. So, let's start with what do you know about TCP? So, why do we even need TCP? Because we want something to be more reliable, like a reliable communication. Reliable communication means no data loss, correct order, and confirmations. So here we have a scenario where we have an online examination. So here the submission has been failed, but the delivery is being safe. So this is the TCP mandate or the core services. So first one is the application view, how it is being done. So here it is being like the process A is being done and then it goes through a series of steps and then it goes to the process B. So it is a process to process mechanism and here multiplexing is being done. So it uses a 16-bit ports here. So here the delivery is continuous, it is connection oriented and it is a full duplex model. And next when it comes to the network view, the reality is like it has an underlying IP layer. So it is connectionless, it is unreliable and it is in not in an order like unordered datagram. So here the reliability is little bit, but when it comes to full duplex, which it means bi-directional flow, and the stream delivery here, there's no message boundaries and these are only bytes. So next we are seeing the bridging speed disparities. So here there's a sender buffer and there's a receiver buffer. So in the sender buffer we'll be having like a written thing and it is being queued and then it has the empty or usable and it has the send or the acknowledgements. So here what happens is from it gives from one application to the network. So first one it is produced by the app and it is waiting for the network and then when it is until the acknowledgement is received it is being held. So in the receiver buffer from the network it is given to the application and here there's two things, one is empty and available, another one is received and so this is the anatomy of the TCP header. So it has the source port, the destination port. Source port is where the data comes from, destination port is where the data goes to, and a sequence number, that is the order of the data, then the acknowledgement, that is the confirmation. So these make the communication more organized. And then we are having the control flags. So these are the uh, uh, control flags that uh, we have for the entire communication process. So here we have different types of control flags, and the first one is urgent pointer, which is valid, which prioritizes the process. Next one is the acknowledgement. It confirms the recipient of the data, and then push function. So here it flushes the buffer to the app immediately. Then the reset here it aborts the connection due to error, and the synchronize here it initiates the connection or sequence number. And the finish, which is gracefully terminates the connection. So next comes the numbering bytes, not segments. So here we have two segments, segment 1 and segment 2. So here the TCP assigns sequence number to the every byte of the data and the counter is initialized to a random number to prevent the context. So this is summary, overall summary. And how do we identify the flag? So we start a connection, then we terminate a connection, then we reset abruptly. So try it out, like which flag is used for which, and then the missing byte mystery. So here, why the acknowledgement number? What acknowledgement number will the receiver send? So here you can see there are three types of segments that is being given, and here the TCP it only reads by bytes and not with the packets. And these are some of the references that I have given, and you can go through it. And TCP is very simple but very powerful thing to be used. And so we'll see about the connections in the forthcoming PPTs. Thank you.